In the third part of lesson 1, we're going to take data from that simulated data from this problem. We're going to copy it into Excel in worksheet L3 of our lesson 1 Excel lab. We're going to copy it into there. We're going to analyze it to answer the questions here. All right. So in the scenario presented in the problem, there's this firm with an office in a southern rural town. A news report comes out and it raised concerns about the hiring practices at this office. You, as the owner of the company, want to determine if discrimination against Black applicants is occurring. For the most recent position filled, there were 176 applicants. The hiring status and the race of each applicant are listed in the table at the bottom of this problem, with applicant's name being replaced by a number representing the order in which their application was received. We're going to use this data to create a pivot table to compute the observed frequencies for this first table, right? And then we're going to use these observed frequencies to calculate the joint probability table and these two conditional probability tables so that we can answer these questions, right? So the first thing we have to do is we have to copy the data. When you copy the data from Excel, you want to copy the values in the table and then like something outside of the table. See, I got submit question also selected, right? I'm going to right click on a number, copy. This is the 176th applicant. This is the 175th applicant. The names have been replaced by the order in which we've received applications. I'm going to delete that. Okay, so now we got to create the pivot table. So I'm going to go up here to insert. I'm going to widen this out. I'm going to go up here to insert. I'm going to click on tables. I'm going to click on pivot table. Excel automatically recognizes that these 3 columns are going to be the data that feeds this pivot table. And I'm going to put the pivot table in a new worksheet. I'm going to hit OK, right? And then I'm going to go back here. And I'm going to see that race is in the rows with white listed before Black. So I'm going to go back to my pivot table here. I'm going to pull race into my rows. Now I want white in row 4 and I want Black in row 5. So what I got to do here is I got to change the order. I'm going to sort Z to A. Okay. And then hiring status is in the columns, right? So I'm going to click on this to bring back the pivot table fields. I'm going to drag hired into the columns. Now, the first column is hired, so that should be yes. And the second column is not hired, which should be no, right? So I need to flip these. So I'm going to come up here. I'm going to click on Z to A. Okay, so yes, hired, and then not hired, right? And then I'm going to drag applicant into values. Now, because applicant is a number, the default when it sees numbers under the variable applicant, it wants to sum. Those numbers are meaningless because they're synonyms for the applicant names, right? So what we need to do is we need to change this to count. Count gives us frequencies, right? Then we hit OK. All right, so now what I'm going to do is I'm going to copy these 4 rows. I'm going to copy them, and I'm going to paste them in my L3 worksheet. I'm going to paste them right here. Paste. As values, right? As values. I'm going to delete the row labels. I'm going to change this to total, then I'll copy that and paste it here. I'm going to change this to hired. And I'm going to change this to not hired. Okay, so the frequency or the number of white and hired applicants was 76. The frequency or the number of white and not hired was 29. The total number of white applicants was 105. The total number of Black applicants and hired was 44. The frequency or the count of black and not hired was 27. The total number of black applicants was 71. The total number hired was 120. And the total number of not hired was 56. And then the overall total was 176, right? And then I'm gonna hit enter and I should get it right. Everything's correct. Okay, so what I want to do now is I want to copy this down here. We're gonna make the joint probability table. Then I'll delete the numbers. Okay. So to create the joint probability table, we need to calculate the probability of white and hired. To calculate the probability of white and hired, you divide the frequency of white and hired by the overall total, 176. Okay. And then you do the same for white and not hired. White and not hired, that frequency is 29. The overall number of applicants was 176, right? Now, a faster way to do this would be to put a $ in front of the 5 to freeze this red box in row 5 and put a $ in front of the H to freeze this red box in column H, right? And then I can reduce the number of decimal places to 4, right? Then I can drag this across and you can see that I got the same exact number, right? Then I can pull it down. These 4 numbers sum to 1, right? This is a frequency distribution. And there are 4 outcomes: white and hired, white and not hired, black and hired, black and not hired, right? This is a frequency distribution, a probability distribution. And all probability distributions add up to 1, which is the case here, right? So I'll type these 4 numbers in: 0.4318, not hired, 0.1648, black and hired, 0.2500, and then black and not hired, 0.1534, right? That is a frequency distribution. There's another frequency distribution, right? And that is the probability of white and the probability of black, right? These are marginal probabilities. These are joint probabilities. Now, to calculate these, I can just drag this over here. And what this shows is it takes the 105 divided by the 176. So there's 105 white applicants and 176 total applicants, right? And then I can drag this down. And this sums to 1, right? This sums to 1. This in itself is a frequency distribution or a probability distribution, right? That because probability distributions or frequency distributions sum to 1, right? So these marginal probabilities here are 0.5966 and 0.4034. So these 2 are a frequency distribution. These 4 are frequency distributions. Then we got 2 more. We got another set of marginal probabilities. To get these, we just drag this down. And when we double click on this, we see that here we're looking at, they got the total number hired, 120, divided by the total. So this is the probability of being hired. And this is the probability of not hired. And those add to 1, right? So that is a third frequency distribution, 0.6818 and 0.3182. Now, these 3 add up to 1, or these 4 add up to 1, these 2 add up to 1, and these 2 add up to 1. So this right here is 1.000, right? Another way to think about that is we're just doing what? We're dividing this 176 by itself, right? Okay. Now we need a conditional probabilities. Okay, so here we're going to look at, given that the applicant was white, what's the probability of hired and not hired, right? So I'm going to do here is I'm going to copy these rows down here, and I'm going to get rid of the numbers. Okay. Now, to calculate the conditional probability here, This tells us that we're conditioning on white or we're conditioning on black, right? So this is the probability of being hired given the person is white. So what we're going to do here is we're going to take the frequency of white and hired, and we're not going to divide that by the number of applicants. We're going to divide that by the number of white applicants. Okay. And we get 0.7238. Then we're going to do the same thing here. We're going to take the number of white applicants that were hired, 29, and we're going to divide that by the number of white applicants, 105. And notice that their sum is what? The sum is 1. So this is a frequency distribution. This is a frequency distribution. And this is a frequency distribution. So there's 3 there. Then there's a frequency distribution here, right? So the probability of hired given the applicant was white, the probability of not being hired given the applicant was white, and then the total of the two, 1.000, right? Okay, now we're gonna do the same thing for black applicants, right? So we take the number of black applicants were hired, divide them by the number of black applicants. We take the number of black applicants that were not hired, and we divide that by the number of black applicants. And then we got another frequency distribution. So we have 1, 2, 3, 4, 5 frequency distributions from this one set so far of data, right? Okay, one thing to note here, this is a probability of hired, this is a probability of hired, and this is a probability of hired, right? Notice that this is more than that, but this is less than that, right? So this right here is a weighted average of these two. If these two numbers were identical, if this were 105 and that were 105, the average of these two, the straight up average of these two, would be equal to that, right? But there are more white applicants. So this has more weight. This number here, this probability here has more weight than that number, right? Has more weight. Okay. So that's why this number is closer to that number, because there's just more white applicants, right? Now, if race were independent, these two both would be 0.6818. But these two numbers are different than that number. So there's a dependency here, right? Hired depends on race, or race depends on being hired, right? Okay. Now we need to calculate conditional probabilities where we're conditioning on hired or not hired. What I'm going to do here is I'm going to copy these 3 columns and put them here. Then I'm going to delete the numbers. Okay. So now we got the totals for hired and the total for not hired, right? So this is the probability of white given hired. This is the probability of black given hired. And this is going to be their total, right? So of the people who are hired, of the 120 people who are hired, 76 were white. So we have 120 people who are hired and 76 of them are white. And that probability is 0.633, right? And then we need of the 120 people who were hired, right? 44 were black applicants, right? And then we're going to sum these. This one pivot table of frequencies gives us 1, 2, 3, 4, 5, 6, and 7 frequency distributions, right? To get this last frequency distribution, I just pulled this over here. So now we're looking at only people that are not hired, right? We're only looking at people who are not hired. This is the probability of being white given you're not hired, right? because we have 56 people who are not hired, 29 of those are white, right? This is the probability of being a black applicant given you're not hired, right? Again, we have 27 black applicants that were not hired, right? And there are 56 applicants not hired. These two numbers are close to that number, right? This number is bigger than that number. This number is smaller than that number. This is the probability of white given hired. This is probability of white given not hired. That's the probability of white. If race and hiring status were independent, these two numbers would equal that number. That's not the case here, right? If these two were identical, if both were 120, then the average of these two would be equal to 0.5966, but that's not the case here, right? All right, so we got our last two frequency distributions, 0.633 and 0.3667, and that totals to 1. Then we got the not hired, right? Probabilities, 0.5179 and 0.4821. And then those two add up to 1, right? What is the probability that an applicant is black and hired? Well, we have to go to the joint probability table. This is the black row, black applicant row, and this is the hired column, right? So the intersection of this column and this row is 0.25. So the probability of being black and hired is 0.2500. What is the probability that an applicant is hired? The probability that an applicant is, this is the hired column, right? Here's the hired column, right? We had 120 people who were hired and 176 people, or 176 total applicants. 120 divided by 176, well, that's this number here, right? So this is the probability of being hired. Given the applicant was black, what is the probability of being hired? So now we have to go to the table with a black total equal to 1. Whoop, right here, 1.0. So we're looking for the probability of being hired. So this is the probability of being hired given the applicant was black. That's 0.6197. Okay. Now, what is the probability that an applicant is white? To get that, right, we had 105 white applicants, 176 total applicants, 105 divided by 176. Well, that was this number here, right? So 0.5966, right? In the total column in the white row of the joint probability table, this marginal probability is the probability that an applicant is white. Now, given the applicant is hired, what is the probability of being white? We're going to get that from this one, right? The total here is under the hired column, right? So these are the probabilities of white or black given the person was hired. So given the person was hired, what is the probability of being white? Well, that's this value, right? Okay, so this is a probability of white. And this is a probability of white. Only we're talking about only applicants that were hired, right? If race and hired status are independent, these two numbers would be identical. Here we have the probability that an applicant is hired, right? Probably that an applicant is hired. This is a probability that the applicant was hired, but the applicant was black, right? They're both probabilities of being hired, but the one in C is given the applicant was black. If race and hired status were independent, these two numbers would be identical. And these two numbers would be identical. These two are pretty close, and these two are pretty close, right? But they're not equal. So we have to say what? There's a difference, And so we have to say that race and being hired are dependent events. When we do a little hypothesis test, and we can replicate this experiment, but we can state the hypothesis and calculate a test statistic. And that test statistic doesn't require this to be equal to that or this to be equal to that. It just requires them to be close